congratulations on achieving the significant milestone of passing the ICC Journeyman exam. This accomplishment reflects dedication and hard work in mastering the knowledge and skills required for the electrical trade. The journey to becoming a licensed electrician involves a comprehensive understanding of electrical theory, practical application, and adherence to safety regulations. The ICC, or International Code Council, develops and publishes a wide range of model codes used in the construction industry, including those specific to electrical installations. These codes are designed to ensure public safety and promote uniformity in building practices. The Journeyman Electrician exam typically covers a broad spectrum of topics, including the National Electrical Code, commonly referred to as the NEC. The NEC is a comprehensive set of standards for safe electrical installations. The exam assesses an individual's knowledge of these standards and their ability to apply them in real-world scenarios. Key areas covered in the NEC and likely to be assessed on the exam include general electrical knowledge, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. General electrical knowledge encompasses fundamental concepts such as Ohm's law, which describes the relationship between voltage, current, and resistance. Ohm's law states that voltage equals current multiplied by resistance. Understanding this law is crucial for analyzing circuits and determining appropriate conductor sizes and overcurrent protection. Other fundamental concepts include series and parallel circuits, power calculations, and the properties of alternating current (AC) and direct current (DC). Wiring and protection focuses on the selection and installation of conductors, overcurrent protection devices, and grounding systems. The NEC specifies ampacity ratings for various conductor sizes and types. Ampacity refers to the maximum current in amps that a conductor can carry continuously under specific conditions without exceeding its temperature rating. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. Grounding systems are essential for safety, providing a low impedance path for fault current to return to the source, thereby tripping the overcurrent protection device and minimizing the risk of electrical shock. Wiring methods and materials cover the different types of wiring methods permitted by the NEC, such as rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. Each wiring method has specific applications and installation requirements. The NEC also specifies the types of materials that can be used for electrical installations, considering factors such as environmental conditions and voltage levels. Equipment for general use addresses the requirements for electrical equipment commonly found in residential, commercial, and industrial settings, such as lighting fixtures, receptacles, switches, and appliances. The NEC provides guidelines for the installation and use of this equipment to ensure safety and proper operation. Special occupancies cover installations in locations with unique hazards or conditions, such as hazardous locations, healthcare facilities, and places of assembly. Hazardous locations may contain flammable gases, vapors, or dusts, requiring specialized equipment and wiring methods to prevent explosions or fires. Healthcare facilities have stringent requirements for electrical systems to ensure the safety of patients and medical personnel. Places of assembly, such as theaters and auditoriums, have specific requirements for emergency lighting and egress routes. Special equipment addresses the requirements for specialized electrical equipment, such as elevators, escalators, and electric signs. These types of equipment often have unique electrical characteristics and require specific installation and maintenance procedures. Special conditions cover situations that may pose unusual challenges or risks, such as installations in damp or wet locations, underground installations, and installations near swimming pools. The NEC provides guidance on how to mitigate these risks and ensure the safety of electrical systems. Continuing education is essential for electricians to stay up to date with the latest codes, standards, and technologies. The electrical industry is constantly evolving, with new products and installation methods being developed regularly. By staying informed, electricians can provide their customers with the safest and most efficient electrical systems possible. In addition to technical knowledge, electricians must also possess strong problem-solving and communication skills. Electrical work often involves troubleshooting complex problems and working closely with other tradespeople. Effective communication is essential for ensuring that electrical systems are installed correctly and safely. To excel in the electrical field, it is crucial to cultivate a strong work ethic and a commitment to safety. Electrical work can be dangerous if not performed properly. Electricians must always follow safety procedures and use appropriate personal protective equipment. Remember that attention to detail and meticulousness are key to ensuring the safety and reliability of electrical installations. The National Electrical Code, NEC, is revised every 3 years, so continuous learning is essential to stay current with the latest requirements and best practices. Several resources are available to aid in this ongoing education, including industry publications, online courses, and seminars. Engaging with professional organizations and participating in local chapter meetings can also provide valuable learning opportunities and networking connections. Specific sections of the NEC that are particularly relevant to journeyman electricians include Article 210. It covers branch circuits, detailing the requirements for the number and type of branch circuits needed for different occupancies and applications. It includes rules for calculating branch circuit loads, selecting the appropriate wire size, and installing overcurrent protection. Article 220 focuses on feeder and service calculations, providing methods for determining the appropriate size of feeders and service conductors based on the connected load. Accurate load calculations are crucial for ensuring that the electrical system can handle the demand without overloading. Article 250 addresses grounding and bonding, outlining the requirements for grounding electrical systems to protect against electrical shock and minimize the risk of fire. Proper grounding is essential for safety and is one of the most important aspects of electrical work. Article 300 covers wiring methods, providing general requirements for installing different types of wiring systems, such as conduit cable and raceways. This article also addresses issues such as protection against physical damage and the proper support of wiring systems. Article 310 focuses on conductors for general wiring, including requirements for conductor size, insulation type, and ampacity. Understanding conductor properties is essential for selecting the appropriate conductors for different applications. Article 400 deals with flexible cords and cables, providing requirements for their use, construction, and ampacity. Flexible cords and cables are commonly used for connecting portable appliances and equipment. Article 430 addresses motors, motor circuits, and controllers, outlining the requirements for installing and protecting motors and their associated control equipment. Motors are used in a wide variety of applications, so it is important to understand the NEC requirements for motor installations. Article 450 focuses on transformers, providing requirements for their installation, protection, and ventilation. Transformers are used to step up or step down voltage levels in electrical systems. Article 500 through 516 cover hazardous locations, providing requirements for electrical installations in areas where flammable gases, vapors, or dust may be present. These locations require specialized equipment and wiring methods to prevent explosions and fires. Some examples of NEC tables that are frequently used include Table 310.16, which provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air, based on ambient air temperatures. This table is crucial for selecting the appropriate conductor size for a given load. Table 310.15b16, which provides the allowable ampacities of insulated conductors rated up to and including 2000 volts in raceways or cables or earth based on ambient air temperature. Tables 220.42, 220.44, and 220.55 are all tables used for calculating loads. These tables are extremely important when calculating the load on service and feeder conductors. Always refer to the latest edition of the NEC and any applicable local amendments when performing electrical work. Local jurisdictions may have additional requirements that must be followed. To further solidify your understanding of electrical concepts and the NEC, consider the following activities. Firstly, practice applying the NEC to real-world scenarios. Secondly, review electrical blueprints and specifications. Thirdly, attend industry seminars and workshops. Fourthly, join a local chapter of a professional electrical organization. Fifthly, seek mentorship from experienced electricians. Sixthly, continuously update your knowledge of the NEC and electrical technology. Seventhly, familiarize yourself with the most commonly used tables. The electrical field is dynamic and ever-evolving, so it is imperative to embrace lifelong learning. By staying current with the latest advancements and best practices, you can ensure that you are providing safe, efficient, and reliable electrical services. Consider additional certifications beyond the journeyman level. Certifications in specific areas, such as renewable energy or industrial control systems, can enhance your career prospects and demonstrate your expertise. Pursuing continuing education units (CEUs) is also essential for maintaining your license and staying up to date with industry changes. Remember that your commitment to excellence and your dedication to safety will set you apart in the electrical field. Approach each project with a focus on quality and a commitment to providing the best possible service to your customers. Your success in the electrical trade is not only a reflection of your technical skills but also your professionalism, integrity, and dedication to continuous improvement. Best wishes for a fulfilling and rewarding career as a licensed electrician.